fix this somehow. So the animations seem to work. Animations seem to work correct. EEG signal, yeah. What's up? Let's see. Can it fix it? Can it fix it? Let's try calling the prompt engineer again. Can you explain the response from the developer?
The developer has made several improvements to the visualization. They've increased the frequency resolution, corrected the y-axis scaling, added new color palette options, enhanced axis labels and grids, refined the arrhythmia generation, and cleaned up the code. These changes aim to make the spectrogram clearer and easier to interpret.
Wow, that will be a lot. Do you think the code will actually work? Can you review the code real quick?
From what I see, the code looks pretty well structured. It includes the necessary HTML elements for the controls in the spectrogram display, and the CSS appears to handle the styling. The JavaScript part, although not fully visible, seems to implement the functionality for the dynamic controls in the spectrogram generation. It looks like it should work based on what I can see.
Well, fingers crossed.
I'm optimistic it will work well. The developer seems to have addressed the feedback thoroughly, and the code structure looks promising. Let me know if you encounter any issues when you test it.
Well, they're still developing the code. Maybe you can do a quick review of the code.
Sure. Based on the code I can see, the developer has implemented the signal generation functions and the FFT implementation. It looks like they're working on the dynamic controls in the spectrogram display. The structure seems sound, and they appear to be addressing the feedback points effectively. It's looking like it should work well.
Okay, so we have the code working. Yeah, it seemed to be well, linear, logarithmic. Yeah, so now we have more high resolution on the frequency on the y-axis.
Yes, the developer has successfully increased. That enhanced frequency resolution provides a much clearer view of the frequency content, making the spectrogram more detailed.
Okay, we have 773 lines of code. Okay, let's test it real quick. There's still a lot of empty space, so when I'm selecting EEG, why all the empty space below the spectrogram?
The empty space below the spectrogram is likely reserved for the dynamic controls that will appear when you select a specific signal type, such as EEG. These controls will allow you to adjust parameters for the selected signal.
No, I'm talking about the space between the bottom of the spectrogram and the x-axis, the time axis.
Ah, I understand. That empty space might be due to the way the y-axis scaling is implemented, especially with the logarithmic scale. It's possible the scaling adjustments are affecting the layout of the spectrogram. The developer might need to fine-tune the scaling parameters to optimize the display area.
So can you explain what the problem might be?
The issue might be that the logarithmic scaling is not fully utilizing the available vertical space. Logarithmic scales tend to compress lower frequencies, which can leave empty space at the bottom of the spectrogram if the scaling parameters are not optimized for the specific frequency range being displayed. Adjusting the scaling parameters or the y-axis limits could help to utilize the space more effectively.
Okay, and also how about the space between the time x-axis and the controls of the spectrogram at the bottom of that section?
That space might be part of the layout and design of the application. It's likely intentional to provide some visual separation between the spectrogram display and the controls below it.
Now that's too much space. Can you explain what the problem might be?
Well, it might be a design choice by the developer to create a clear separation between the spectrogram visualization and the control elements. However, if it appears excessively large, it could be due to specific layout settings or the use of padding or margins in the user interface design. Adjusting those spacing properties could reduce the gap to make the layout more compact.
Okay, let's see if that helps. Can you give an overview of what is it we are trying to do?
We are trying to optimize the visual representation of the Interactive Spectrogram Generator. The main points are to improve the frequency resolution, adjust the y-axis scaling for better visualization, enhance the color palette options, make the axis labels and grids clearer, refine the signal definitions, and address the spacing between the spectrogram and the controls. The overall goal is to make the application more accurate, clear, and user-friendly.
And what's the developer's response at the moment?
The developer acknowledges the feedback regarding the logarithmic scaling and layout spacing. They plan to correct the logarithmic scaling logic, increase the frequency resolution, adjust the padding and margins for a more compact layout, and enhance the grid lines to improve the spectrogram display. They are also updating the code in Canvas based on these changes.
So does it look like the user is able to change so currently the user is able to change the type of y-axis from linear to logarithmic and the color map, but are we able to change the range of the frequency and the time window?
Based on the current view, it looks like the user is not able to directly change the frequency range and time window from the visible controls. The controls available are for the signal type, y-axis scaling, and color map. The frequency and time values might be predetermined or adjustable through other settings not visible in this view.
Okay, and should we be able to control the frequency and the time range? What do you think?
Yes, it would be beneficial to have the ability to control the frequency range and time window. This would allow users to focus on specific frequency bands of the signal or analyze different time periods, making the spectrogram generator more versatile and useful for various analyses. It would also enhance the user's ability to explore the data more effectively.